Alright, real briefly here guys, higher order derivatives. This won't take very long, just a short little explanation. Let's say f of x is our original function, or sometimes we call it the position function when we start talking about doing some physics examples eventually, okay? We're not really going to get into too many physics examples yet today, but f of x is going to be your original function, your position function, where an object is located, okay? F prime of x, just the one little apostrophe, okay, right there, a little tally mark. That's referring to the first derivative. That is the derivative of the original function. And you guys know it represents velocity. We've talked about that. What are the three interpretations of the derivative? You've had that question on a test before. One of your answers is instantaneous velocity, okay? So first derivative represents velocity. Just know that if we see f prime of x, that's referring to the first derivative of f, okay? Or the slope of the tangent line to f, okay? F double prime of x, if you see that notation, all that means is take the derivative of the derivative. So do the derivative once, then do it again, okay? And so on and so forth. But that's the second derivative. It helps you figure out acceleration when we get into physics problems, okay? So f double prime of x is your second derivative. F triple prime is your third derivative. It references jerk as far as physics is concerned. Again, we don't work too much with that. Anything else past the third derivative, it looks like our textbook likes to use just kind of a little number up there in parentheses to tell you that represents the fourth derivative, the fifth derivative, the sixth derivative. I don't really know a purpose for all of those. All right, I'm not quite aware of what they would all represent as far as applications to a real-world situation. I'm not familiar enough with that to know. But again, in Calc 1 especially, we'll get you about the second derivative, and that's really all the further that we would ever go with this. Okay? It's really pretty simple. Do the derivative once, take that answer, do the derivative again. Okay? Sometimes the second derivative becomes easier. Sometimes the second derivative becomes harder depending on what type of function you get after doing the first derivative. So any questions that you can see right now on this? Okay. Let's maybe do one together. That might be a little bit tricky. Let's do... Let's say f of x equals x tangent x. Never mind. That's going to require a chain rule to do the second derivative.
A chain rule?
Yeah. Let's do this.
No.
This won't. Sorry. To do the first derivative, what are we going to have to do? Product rule. Okay. So f prime of x will equal 1. What's d2?
Negative cosine.
Negative sine.
Oh, sorry.
Plus 2.
I wrote the wrong thing.
d1. 1. So to summarize, my first derivative will be negative x sine x plus cosine x. So that would be your first derivative. But if I want to know then the second derivative, I'm going to take the derivative of this. This has two separate terms. It's got a negative x sine x, and it's just got cosine x. To do the derivative of negative x sine x, you're going to again need to do the product rule. But to do the derivative of this, it's just simply negative sine x. But let's not make sure we don't forget about it. Okay? So the second derivative will be 1. What's d2? Cosine x plus 2. What's d1? Negative 1. The derivative of negative x would be negative 1. And then don't forget back here, what's the derivative of cosine? negative sign.
Oh, that's a good
Okay? You may think some of my parentheses are a little bit too much. As calculus gets more and more complicated and some of your steps get longer and longer, I really think it's important for you to see everything kind of with its parentheses. I think it helps you when it comes to simplifying. It helps you keep everything straight and organized. But if you don't need them, you don't need them. Okay, some of you can do it without. I just know when problems get very, very long, I like being very organized and showing my work all the way through. Okay, let's simplify this real quick. Negative x times cosine x. Exactly that. Minus sine x. Minus sine x. So I would probably negative x cosine x minus 2 sine x. There'd be my second one. Okay? So again, you're just going to have a little bit of practice at those today. They're not overly difficult. So far, they're probably not even going to use any of our new, the new chain rule that we're doing here in a little bit. So, any questions on what higher order derivatives is referring to?